So year 3, apart from in kindergarten, every year starts with place value and then it continues all year. And again, I'll show you here. We've got place value, term 1, place value, term 2, place value, place value. So you can see in year 3, we're focusing on it at least half an hour, sometimes an hour and a half, sometimes an hour a week. They're also doing multiplicative place value. For year 3, this is a decision you've got to make. They're supposed to be adding and subtracting 3-digit numbers in year 3, and they're meant to be using mental strategies because the algorithm doesn't come in till year 4, and the algorithm's not mandatory. With addition and subtraction though, because your year 3s haven't come through necessarily with the deep understanding, they're going to have to drop back to the year 1 level, which is bridging 10. Because if they can't bridge 10, they're not going to be able to bridge any other place value. So even though they're year 3, in the beginning of the year, I would drop them back to the year 1 level. Down here it's got differentiating up and down, adding and subtracting single digit numbers, bridging 10 is one way that you can differentiate down. In the very first lesson with year 3, the same as I did in year 2, I would put up adding counting by ones on a number line, adding bridging 10, and then I would say, show me which one you can do. And you can already do the counting by ones, try the bridging 10, see if you can work that out, particularly if they've never seen it before. And do it with subtraction too. From that, in the first 2 lessons, you've now found out, okay, what kind of place value understanding is in the class already. Did any of them work out how to bridge 10 if they haven't seen it before? Or if they have seen it before, did they try to show it to me? So that will give you an idea of which kids are still counting by ones. That's fine. If they've got counting by ones, their next level, which is their next level of productive struggle, is bridging 10. Basically, year 2, 3, and possibly 4 might look very similar initially, but you will find that your year 3 and 4 kids, a lot of them will move faster. So they'll get up to the year 2 level faster, and then again, they might be up to the year 3 level by, say, term 3. This is where you can make a decision with your year 3 and 4 kids. The kids who are just stuck, still can't bridge 10, still can't bridge 10, still can't bridge 10. You then use your teacher professional judgment of, I'm just going to teach these kids the algorithm, because the algorithm you can do counting by ones. So it's not their fault that they didn't get this. If they'd got this in year 1 and then in year 2, they would already have it. But because they weren't exposed to it, and you might only have 1 or you might have half your class. And again, it's teacher professional judgments. Okay, let's look at their books, let's look at what they're doing. And the most important thing in all of this is the teachers have to collect the books every single lesson. So again, in year 3 and 4, you might start at the year 1 level for them, and then you've got the levels up, and again, take levels down that no one's using anymore, so you're not going to have a zillion levels on the wall. And then when a child's ready for adding and subtracting 3-digit numbers, it's just another level, and then another level, and so on. And it's the same with teen number, 20s and 2-digit place value, 3-digit, 4-digit. When no one needs teen anymore, take it down. When no one needs 20s anymore, take it down. So again, you will find that kids are going to be maybe working on lower grade levels for the first half of the year, but in year 3, we start teaching multiplicative place value. So what we want is kids to start thinking multiplicatively in year 3. Now you'll see that that's taught at exactly the same time as metric length. And I always do length in term 1 because it's 1 dimension, we're just measuring a line. Area in term 2 because it's 2 dimensions. And volume and capacity in term 3 because we're measuring 3 dimensions. And then in term 4 we do mass because mass is non-spatial. You can't actually see mass. So we're still measuring 3 dimensions of something, but not in a way that you can see. Metric length is based on multiplicative place value. What multiplicative place value means is if I have 1, I multiply it by 10, I get 10. I divide that by 10, I get 1. Now thinking about that multiplicatively doesn't mean that I have 10 ones. It means I've made 1 10 times bigger than it was before. And if you even say to year 1 and 2 kids, if you say show me 1 and then say show me the number that is 10 times bigger, they go like that. Kids in year 3 will do it naturally. They know that 10 is 10 times bigger than 1. Now show me the number that's 10 times smaller, and they go like that. That's what division is. So if kids see multiplication multiplicatively, as in I'm making a number 10 times bigger, now when I divide by 10, I'm making the number 10 times smaller. You can see that I also teach that at the same time as multiplying and dividing by 10. So we're not adding zeros to anything. If I want to make 1 10 times bigger, it's got to go into the column on the left, because the column on the left is 10 times bigger. Now this links to the metric system, because 1500 years ago the Hindus invented place value, and that was only from ones. So they only had whole number place value. So they had ones times 10 is 10 times 10 is 100 and so on. So they could write really, really big numbers really easily. And then finally about 1200 the Europeans started using it. So then about 500 years ago, European and Arabic mathematicians decided to extend multiplicative place value to fractions, decided to divide 1 by 10 to get a tenth, and then divide that by 10 to get a hundredth, and so on. And then 300 years ago, the French invented the metric system. And what they did was they started with a meter, they divided it by 10 to get a tenth of a meter, which they called a decimeter. Deci means tenth in Latin. They divided the decimeter by 10 to get a hundredth of a meter. Centi means hundredth in Latin. Divided that by 10 to get a millimeter. Milli means thousandth. In year 3, we don't tell them the meaning of centi, milli and deci. We just tell them they exist. Now, most teachers don't teach decimeters. And what a lot of teachers say is you go multiply by 10. So millimeter times 10 is a centimeter. Multiply by 100 and then multiply by 1,000 is a kilometre. It's actually all by 10. And if you teach it this way, related to multiplicative place value starting in year 3, just multiplying and dividing by 10, and that's what the metric system does. So first of all, they just had length, then they turned the length units into squares, area, then they turned the length units into cubes, volume and capacity. For measuring volume and capacity of objects with curved surfaces, they use the same prefixes. So now we have litre. Divide a litre by 10, we have a tenth of a litre, a decilitre. Divide that by 10, we have a hundredth of a litre, a centilitre. Arabic countries and European countries measure in centilitres. So it's 75 cl instead of 750 ml. And then you divide that by 10, you get a thousandth of a litre, and so on. And then when you get to mass, it's the same. So you've got a gram, divide it by 10, a decigram, divide it by 10, a centigram, divide it by 10, a milligram. And you go up the other way, so you get up to kilogram. If kids start learning this in year 3, they start to see the relationship between multiplicative place value and metric measurement makes it visible, because they can see things getting 10 times shorter and 10 times longer. And they physically use their arms to show this. It just makes so much more sense to kids. Multiplying and dividing single digit numbers in year 3 and 4. That's basically your tables. But it's not just your tables, because it's division as well. And the same as when I said, when you add and subtract, it's really important the kids are at the same level for addition and subtraction. It's the same with multiplication and division. So if you just teach tables, and then, which is multiplication, and then later on teach them division, they're never going to relate them. They're never going to realize that it's exactly the same thing. So the way that I teach multiplication and division, I start with multiplication and division by 2, because that's obviously the easiest one. And we look at the distributive property, because we want to wean kids off skip counting for 2 reasons. Number 1, skip counting means that they're thinking of it as groups, which means that they're thinking additively, because they've got a group of 2 plus another group of 2 plus another group of 2 plus another group of 2. So that's additive thinking. And again, we want them to think multiplicatively from year 3 onwards. And that's why there's no real multiplication and division until year 3. because up until then the kids are thinking additively. The other reason is because it's just too slow. If I wanted to do 2 times 5, I could go 2, 4, 6, 8, 10. That doesn't take long. But what if it was 2 times 65? I can't go count by 2s up to 2 times 65. So it's not an efficient strategy. An efficient strategy means it works in all situations. I don't need to learn any other strategies. And the other reason is it's additive. So what we want them to do is we want them to use the distributive property. And so you've heard of the area model and that kind of stuff. That's the distributive property. The distributive property just means, say I don't know what 2 times 6 is, but I do know what 2 times 5 is. I can partition the 6 into 5 and 1 and say 2 times 5 is 10 and 2 times 1 is 2, add them together and I get 12. Now, 2 things about that. Number one, it's the distributive property, and we want kids to know that we distributed our multiplication over addition, which means when I didn't know what 2 times 6 was, I chose an addition to distribute the 6. So I distributed the 6 over 5 plus 1. That's why it's called the distributive property. We want kids to know they're using the distributive property. We don't want to make up other names for it. We want to actually tell them it's the distributive property. The distributive property works no matter what numbers you ever want to multiply or divide. It works for division too, because if I divide by 2, I'm actually finding a half of the number. So here where it says relating it to fractions, I'm relating dividing by 2 to halving. Then when they get to year 5 and 6 and they have to multiply by a fraction, they know that when they divide by 2, they're multiplying by a half. So it all just flows. Now in year 3, I've even had kids who don't know what 2 times 2 is. So they literally go 2 times 2, they partition the 2 into 1 and 1, and they go 2 times 1 is 2, 2 times 1 is 2, which is going to be 2 plus 2, which is 4. And it works with any size numbers. So I can do 8 times 365 at year 5 level, even later on in year 4 level. I can go 8 times 300, 8 times 60, because I know about that multiplying by 10 and how digits are moving. And I can do 2 times 5. You can divide. If I was going to do 365 divided by 8, I don't need an algorithm. If I'm dividing by 8, I know that 360 is 320 plus 40. So I can partition 365 into 320 plus 45. And I already know that 320 divided by 8 is the same as 32 divided by 8 times 10. This really deep understanding of multiplying and dividing happens across year 3 and 4. So it's much deeper than just learning tables. And in the syllabus it says multiply by 2, 3, 4, 5 and 10 in year 3, and then 6, 7, 8 and 9 in year 4. That's because you don't have to learn 6, 7, 8 and 9. If you know up to 5, you can partition everything into 5. And not only that, they're not just learning tables, they're learning the inverse relationship, because they're going to learn how to multiply by 2 when they know enough multiples without too much cognitive load. They're then going to divide by 2. Then the next one I do is 4. And doubling is fine. Halving and halving doesn't always work. So again, doubling and doubling is okay, but they need to still use the distributive property, because if I'm dividing an odd number by 4, say 35 divided by 4, and I halve it and I get 1 left over, I don't know what to do with that 1. So halving and halving's not an efficient strategy. I mean, obviously I show those and I teach those, but I also teach it's not an efficient strategy because it doesn't work for division all the time, or it makes division much harder. The distributive property always works. And not only that, the reason I do 4 after 2 is because it's related to 2. Then all of term 3 is spent on nothing except multiplying and dividing by 3. Now, of course, you've got the anchor charts up for 2, and you've got the anchor charts up for 4. So the kids who are still working on them, still investigating them, keep doing that. The kids who are ready can go on to 3. And then once the kids are ready, they go on to 5. I think the most important thing for year 3 is this additive, place value and addition and subtraction. If I'd go back down to the year 1 level and build up, this you want to start at grade level, because this is the first year you've ever taught multiplicative anything, because it only starts in year 3. While continuing that, bring in the multiplication and division.